Okay, so next video is 149, line 18A, 3z2a3c, called Ultrarelativistic Wind Crab Pulsar Neutrinos 5G Wow Seti. I didn't get to give you the last PDF from the last video, the role of E plus E minus linear collider in the study of cosmic dark matter from Gallia. So I'm going to add that into this one. And the title of that video was line 18A, 3z2a3b, evidence of supersymmetric Higgs mass CMSSM SUSY Wow Seti. So I'm just going to scroll down here and finish this PDF file that we missed. Okay, so we're going to start here, between here and here. Okay, so it says new well, there's a number there, and then the role of E linear collider, study of the cosmic thing from Gallia, Department of Physics, University of California. Okay, and there's his email contact information for you. So the abstract is the potential of a high energy, high luminosity E plus E minus linear collider in the study of a weakly interacting massive new particle, as the cosmic dark matter candidate is reviewed with special emphasis on supersymmetric scenarios. Results of detailed simulation studies for supersymmetric neutrino dark matter indicate that the accuracy from linear collider data of sufficient energy may allow us to infer the dark matter relative density to accuracies comparable to those already obtained from the study of cosmic microwave background and other astrophysical data, thus providing a powerful test on the nature of dark matter by combining results from particle colliders with satellite and direct detection experiment data. And then I also read you my thoughts already. I wasn't able to look up the keywords because 497 pages came up with the letter E. So when I do the cross sections, I hope this will stick with me. So here are the tags for this last video. And I wasn't going to read those because those are in the first one, AZ. Okay? So I'm going to go into the next one, part 149. There's a SETI signal, and it says abrupt acceleration of a cold ultrarelativistic wind from the Crab Pulsar. And that was written from F.A. Aharonian and S.V. Boglov, 2012, and it says it looks like it was published on 2011 in December, and they put it on this website February 15, 2012. So it just came out about a week or so ago. And that's the high boson there. Okay. Pulsars are thought to eject electron-positron winds that energize the surrounding environment with the formation of a pulsar wind nebula. The pulsar wind originates close to the light cylinder, the surface at which the pulsar co-rotation velocity equals the speed of light, and carries away much of the rotational energy lost by the pulsar. Initially, the wind is dominated by electromagnetic energy, pointing flux, but later this is converted to the kinetic energy of bulk motion. It is unclear exactly where this takes place and to what speed the wind is accelerated, although some preferred models imply a gradual acceleration over the entire distance from the magnetosphere to the point at which the wind terminates. A rapid acceleration close to the light cylinder cannot be excluded. Here we report that the recent observations of pulsed very high energy Y-ray emissions from the Crab Pulsar are explained by the presence of a cold in the sense of the low energy of the electrons in the frame of the moving plasma, ultrarelativistic wind dominated by kinetic energy. The conversion of the pointing flux to kinetic energy should take place abruptly in the narrow cylindrical zone of radius between 20 and 50 light cylinder radii centered on the axis of rotation of the pulsar. It should accelerate the wind to a Lorentz factor of that. Although the ultra-relativistic nature of the wind does support the general model of pulsars, the requirement of the very high acceleration of the wind in a narrow zone not far from the light cylinder challenges current models. Okay, and there's a figure there. Pulsed wire emission of crab. There's your parameters, wind emission, energy, and I don't know what this is, flux. Pulsar emission. Okay, and that's what it looks like. Okay, so this is the spectral energy distribution of a wide array radiation produced by the pulsar magnetosphere and by the pulsar wind. That's at www.nature.com. Symbols show the reported Y-ray fluxes with 1 st error bars. Curves show theoretical predictions this work. The Fermi Large Area Telescope points are best fitted by the function of that. And that. Okay, and that's from www.nature.com. Figure 2 is a complex comprising of the pulsar magnetosphere, the ultrarelativistic wind, and the pulsar wind nebula. That's what this one is. So you look at it. Pointing flux dominated wind. Here's a view of it there. Dense electron E, positron E plasma produced in the pulsar magnetosphere by pair creation processes. Initiates an electron-positron wind at the light cylinder, which has a radius of this. Initially, the rotational energy lost by something. www.nature.com. Figure 3 is the formation of the pulse VHE Inverse-Compton Y-ray signal in the wind of the crab pulsar. And that's what that looks like. I'll give you a close-up here. And can't really read it. It's kind of blurry, eh? Blurry for me too. Okay, so a geometry of the inverse Compton scattering of magnetosphere X-rays by the electron-positron wind. B. Theoretical Y-ray light curves of the wind presented together with the reported VHE data. The velocity of the accelerated wind is ta. February 21st, 2012, my thoughts, quote, here we report the recent observation of pulsed very high energy Y-ray emission from the crab pulsar are explained by the presence of a cold in the sense of the low energy of the electrons in the frame of the moving plasma, ultrarelativistic wind dominated by kinetic energy. Okay, I see the keywords for high energy here. We have Y-ray emission, we have pulsar, cold, electrons, moving plasma, ultra and relativistic, wind, and kinetic energy. All keywords found in the lines of data in the Wow Seti signal. I'll have to see where this goes, and again, there's the tags. Okay, so that's the end of that video, and we're going to go on to the next one.